Hi everyone, I'm Jim Houchel and welcome back to the Old Radio Revival. Before we dive into today's project, I want to talk about something fundamental to what we do here and how it connects to something far, far greater. For many, restoring old radios might seem like just a hobby, a niche interest, a way to pass the time, fiddling with wires and tubes. And sure, it's enjoyable. But for me, it's so much more. It's not just about the electronics, it's about bringing back a piece of history, memories of forgotten voices, old music that once filled homes, and stories from a bygone era. Each restored radio is a tangible link to the past, a piece of history that now sings again. It's about restoring connection, memory, and even a sense of wonder. Now, here's the parallel. The gospel is the same. It's not just a religion. It's not just a set of rules or a Sunday morning activity or something you do when you have free time. The gospel, the good news of Jesus Christ, is about restoring life, purpose, and eternity. It's about taking a soul that is lost, broken, and disconnected and bringing it back into vibrant, living relationship with its Creator. The world often tries to categorize faith as just another hobby, something you engage in if you're into that sort of thing. But the Bible tells us that the gospel is a matter of life and death, of eternal significance. John 3:16, one of the most famous verses, declares, "For God so loved the world that he gave his one and only Son, that whoever believes in him shall not perish, but have eternal life." This isn't a casual invitation to a pastime. It's an urgent call to embrace the path to everlasting life. Don't treat the gospel like a hobby. It's not something you pick up and put down when it's convenient. It's the most important decision you will ever make because it determines not just the quality of your life here, but your destination for eternity. It's about finding true purpose, meaning, and a relationship that transcends everything else. When you commit to Christ, it impacts every aspect of your existence, transforming your present and securing your future. So, as we dedicate ourselves to restoring another piece of history, breathing new life into its circuits and cabinet, I urge you to consider your spiritual life. Is the gospel just a hobby for you, or is it the foundational truth upon which you build your entire existence? Embrace it as the ultimate restoration project for your soul. Now let's head over to the workbench.
So this is the capacitor that we switched out together. Since then, I switched out the capacitor in this block and two in this block here. But before I switch out the two capacitors in this block, I wanted to point out something that you may have already noticed. In the picture we've been using, you may have noticed that some of the components are in different places. For example, this wire wound resistor is on the schematic on our picture is at the top up here by the switch. And under that is another capacitor. It's an electrolytic capacitor. But under the chassis, we find that the electrolytic capacitor is no longer there. The wire wound resistor is over here. And the two blocks that we saw in the picture that were over here are now one block. So what's going on here? Well, over a period of time, they made some upgrades to the radio to improve its quality. And that involved eliminating that electrolytic capacitor. And in its place, they put a 0.015 microfarad capacitor. And as you can see here on the schematic, that's the same as the line filter capacitor over here on this side. So what they've done is combine the two capacitors, not combined them, but placed them both into one block, eliminating that other block. The other block that they eliminated was another capacitor that they eliminated. which was number 38 here. So what I did was I went to a website called philcoradio.com, and they've got a ton of information on there if you are restoring a Philco radio. It's very helpful to you. This is where I pulled this other schematic off of. It's an updated schematic, and so we're going to look at it as we move forward. So I thought we would switch out the two capacitors in this block together, because one of those, as we saw, was a line filter capacitor. So what is a line filter capacitor? Well, that eliminates incoming noise to the radio. It takes that unwanted noise and puts it to ground. It also eliminates any noise coming from the radio and takes it to ground. So what we want to do is put a safety capacitor back in place of that paper capacitor that was in there. Those paper capacitors, when they failed, it was likely to fail as a short circuit, which was a direct path for the electricity. This would potentially put 120 volts directly on the chassis, which could cause a severe electric shock hazard. So we want to put in there a Class Y capacitor. That's a safety capacitor. They're specifically for lined ground applications like this. Y capacitors were designed to fail as an open circuit, so it would break that path to ground. This would ensure that even if the capacitor fails, it doesn't create a hazardous condition between the AC line and the chassis like you would have with the paper capacitor. So I wanted to go through that with you, let you watch that process, and let's start there. So if we look at the schematic, we see that both of the capacitors in that block are connected to ground. And that would be this lug here that they're connected to. On the line filter capacitor, the other end of that is connected to one end of the primary winding, which should be the neutral line of the power cord. So if we look on here, we see that this lug here has two wires on it. One does go to the transformer, and one goes to the power cord. So that is going to be where we place our safety capacitor on each of these two lugs here. The other capacitor then will be placed on one lead here on this lug, and then over here onto the ground as well. So let's do that. Let's get these unsoldered and then go from there. What I'm going to use is a little bit of solder wick. I have a solder sucker, but it's not playing nice today. So let's use some of the solder wick to get some of that excess solder off of those joints, and that'll help us see those wires a little better. So you put this on here, you make sure that it's hot enough. Put this on the joint, on top of the joint, and then your soldering iron on top of it. Heat it up, and eventually then it sucks up, kind of soaks it up like a sponge, that excess solder. So there's not a lot of excess on that one. Let's do this next one. Getting out. And then this last one over here. Just be careful, that ribbon gets hot. Alright, so it's soaking it up good there. Oh, it's actually soaking out the tar from inside. Let's clean those up just a little bit with some alcohol. see a little better what we're doing. All right, that's a little better. All right. So we got them all loose. Now we can go inside and pull them out without any trouble. Just like before, we will take off this bolt. And carefully turn it over. Then we'll get some foil behind here, heat this up, pull that out, put in our new capacitors. Now make sure you get your foil around that so that you don't inadvertently heat up that wire wound resistor, melt the wires on that or something. That's something I would do. But let's go ahead and get this thing heated up and get that tar out of there. Here we go. And here's the other one. And because we unsoldered those wires on top, they came right out. All right, let me get this cleaned out of here and then we'll come back. We got that all cleaned out. Now these are the two capacitors that we're going to put back in that block, the 0.015 microfarad capacitors. This is the safety capacitor that I was talking about that will replace that line filter capacitor. So we'll get those back in there. We'll put this safety capacitor in first. And it was on this end here and in the middle hole and on this end hole. So we'll slide that in there. Just like that. And then we'll get our other one. And put it in there as well. Now this post here on the end, as you recall, was our ground post. So I want one end, one lead to go across to that hole, and then the other will be at the other end. Put those in there. Slide it down. Like that. so we've got our leads sticking out the correct holes over here. We can put our block back on the chassis. Get the hole lined up. Stick our bolt back in there. Get it lined up a little better, apparently. Now we're cooking. All right, we got that on there. Now let's get these leads soldered down on these posts. Start with the ground leads here. I'm going to wrap one around post here. And the other, maybe around this other post. Maybe. Get my pliers to work. Like that. And we'll solder those up and trim them off. Put this middle one on its post. And then the other end. I did clean those posts up with alcohol so that we'll have a good contact there. All right, let's get some solder on it. Should have put some flux on here first, but I didn't. That's okay. It'll still work. Clean the excess rosin off that new connection. Now let's check this wire wound resistor. I want to make sure that I didn't inadvertently get it too hot and cause some kind of damage. If we look at the schematic, it shows that that wire wound resistor should be 325 ohms. So we've got our meter set up here. Got it set to 2K. Let's just put our leads on both ends. Ooh, look at that. 325 to 326 ohms. So it is almost right on the money. That's the good thing about those wire wound resistors, is that they are pretty darn accurate. And luckily we didn't cause any damage to that one. We got those those capacitors replaced that were in the blocks. Now we need to replace the electrolytic capacitors, which are in these two towers on the, or the cans on top of the chassis. So we'll flip this chassis over, see if we can get the cans off. See what, I'm not sure if I'm going to be able to get the contents out of the can, or if I'm just going to have to take the wires off the can and place the new capacitors somewhere on the chassis. I was going to flip that over, but I think what I will do first is remove the wires from this particular electrolytic. It's got two here and two here. So this one's pretty easy to get to. I'll remove those wires and then take this, then I'll flip it over and take this particular can off of here. Then we'll see how difficult it is going to be to remove the contents or not, and go from there. So first thing I'm going to do is remove these wires. All right, I'm going to use some of this solder wick to get some of this excess solder off of here so that maybe I won't have to clip the wires like I did before. See how well that goes. You'll want to keep track of which wires came off of which connections, of course. Okay, looks like that worked pretty good. So let's see if I can get that first one off of there. Or not. Okay, got one of them off of there. And got the other one off. Okay, I eventually got those other two leads disconnected. I flipped this over now, and we are going to remove this can right here. So it's on here by a couple of little bolts. Should lift off there. All right, so here's what it looks like. So within this can is that one capacitor, which is, I believe it was an 8 microfarad capacitor. So how do we get it out? I wish that screwed out, but I'm sure it does not. And I really don't want to tear it up. Let me get a wrench. Okay, I've got a wrench. This is very hard material, and no, it does not screw off. It is on there very well. Now I could take a drill bit. I'm sure I could hacksaw this off, use a drill bit,
get the innards out enough to put a new one in there, because I really don't need this bottom part. But I think I'm just going to put the new electrolytic capacitor underneath the chassis down there, out of the way, and hook those wires that was hooked up to it, to the new capacitor. So let's get this one back on. If you look at the schematic in our parts list, you'll see that this is a 8 microfarad and this is a 4 microfarad electrolytic capacitor. So we are going to switch them out with 10 microfarad capacitors at 450 volts. This is an aerial capacitor. This one happens to be an axial. Aerial has the leads coming out of one end, and the negative side is marked with negative. And on the axial, the negative side has arrows pointing to that particular end. So we're going to switch these out. I'm going to use this one on the one that we are going to start on over here. And I think what I'm going to have to do is put a terminal strip down in order to hold this thing in place. There's not really any good place to keep it from moving around too much. So I'm going to put this terminal strip down there. There's a little hole just under this block. So I'm going to have to move this block out of the way just a little bit. So we'll pull this back just a little. Not sure if you can see the hole down there. Right in there. But we're going to put this terminal strip there. Now if we use the middle post, you would see that that would be against the chassis, so that would be a chassis ground post, but we're not going to use that. We're going to be on these two outside posts. So I'm going to set that down in there, try to. Actually, I think I'll put the screw in first. To it like that. And then we'll see if we can get it in that hole. You have to get a screwdriver to, not sure if the hole is, yeah, it's big enough. Swing this around in the position we want it to be in. Like that. Now I'll go up underneath with a little star washer so it'll grip onto the chassis when I put that nut on there. So put the star washer against the chassis and then the nut. I'll hold the screw down with a screwdriver so it doesn't pop back out while I'm trying to do this. I got it started. Okay. Use my screwdriver to tighten that up. That's good and tight. I'll put this block back. Yeah, I'll put the block back down last so we can get to this. Now, as you recall, there were two wires on the negative side of this terminal, or negative terminal, and then two wires on this positive. These were the two wires that went on the positive, and this one are two negative wires. So we'll put the two negative wires on this farthest inside terminal, and that will be the negative lead that we will put on there as well. So I think what I'll do is I will set this, against the chassis like that, and then bend those terminals to go into each of those, or bend these leads to go into each of those terminals there. So that's what we'll do next. So I think I will just start by putting that in that hole, grabbing the back side of it so I can bend it around. Do the same with this one. Should have started with it since it's longer. Go through the hole. And I'm going to set it up like that. Bring those leads around that terminal post. Same on this side, like that. Now, this was a negative, so it's going to go in to the negative side. I kind of twist that wire around that terminal post. Then, let's see, this was the other negative wire. Let's see if there's enough room left in that hole to stick this one in it. And twist it around as well. So we've got our negative set up. Now we need to get these two wires into the positive side. Can come through the back side on this one. And come through the front side on this one. Hope I get these right because they will be boogers to undo. All right. So, got the wires in there. Let's put a little flux on them and some solder. We'll be done with that one. good. That one seems to be tight, and I can tell that's on there well. All right, so they're all on there very well. Take some alcohol, clean it up a little bit, get that flux off of there, any rosin. Got some nice clean joints here then. Connections, I should say. Let's get our block here back in place. And that is not going to move around in there. One thing I did want to mention, what if you can't tell which side is your negative and which side are your positive wires here? I mean, it's relatively easy for us to figure out with this one, but in some cases you may not be able to figure it out as easily. So what do? Well, if you'll take a look at the schematic, you'll notice that those two electrolytics are connected to the center tap of this secondary. That center tap is the negative most point in the circuit. That is going to be your negative side for those electrolytic capacitors. So that's just a good rule of thumb. Check for that center tap, and that side is what's going to be connected to the negative side of your electrolytic capacitors. So let's move on to this other electrolytic capacitor. This was a 4 microfarads, and we're going to put 10 in there. We're going to use an axial lead on this one. Not sure, I don't believe that will be able to, or need to use a terminal strip. We'll decide that, I guess, as we get a little further along here. But this, again, is a 10 at 450 volts. First thing I want to do is get these resistors out of the way so that we can get that capacitor down against closer to the chassis. Remember we talked about this one being hot, burnt. It shouldn't be black like this. What they've done, this is a 16,000 ohm resistor. And it's like a 1 watt, I believe, probably, that size. They've replaced it. In fact, if you'll notice, this end's not even attached. So they've clipped off that end, and they've put in another capacitor, 16,000 ohm, but this is more like a 2 or 3 watt. And they did that to allow it to dissipate more heat without burning up like this one did. So apparently this is going to put out a lot of heat, and we will replace this, both of these. I think I'll put a 5 watt in there just to be on the safe side. But right now I just want to get them out of the way so that we can work on this capacitor. So if we remember, we'll have to remember that this is connected on one end to this block here, this end of the block, and the other is to the positive side of this capacitor. So one thing I do in the beginning, one thing we did was take pictures. And that picture will help you in case you forget, because things happen. I mean, you could get called away and it's, the next day or two before you ever get back to this, and you've already cut those off and you're trying to remember, where did I cut those off at? Where do those go back? A picture will help you to see that pretty quickly. Also, you could do a little sketch. I've done both. But let's go ahead and clip those off of there. This capacitor also has a wire connecting to the positive side of this capacitor. This wire goes back here, and when I was looking at the schematic earlier, I noticed it goes back to the speaker section. So we'll want to make sure that we get that back onto the new positive side.
See if I can cut that loose. Cut that one off. Cut it off on this end. Just for the fun of it, we'll check the resistance in this and see if it's still good or not. It's supposed to be 16,000 ohms. Looks like it's gotten a little hot too. So it might be a good thing we put a 5 watt in there. We'll see. Got those out of the way. Now, there's another one here. That may be out of the way enough we don't have to worry about it right now. Let's get these wires off of here first. That one came off easy enough. Wish the others would. Now I could use this post that I'm taking these wires off right now as my negative terminal. Be nothing wrong with that. The only reason I'm not doing that is because I want to, when I clean the chassis on the top side, those cans were easy and so easy to get off that I want to be able to take them off and clean them up, make them shine again. And it'd just be easier to do that when they're not still attached to the chassis. So that's kind of the reason I don't want to use these posts, is because I won't be able to take those off. Okay, got one of these off. There's 3 wires connected to the negative end here, negative side. And we just got them all off. So, all right, so we got all those off. One thing I just noticed that I thought I'd point out to you was there are not 3 wires here as it appears, but there are 2. Instead of using a 3rd wire, what they've done is taken 1 wire, attached it to where they're going to attach both ends to it. They've taken this 1 wire and removed the insulation from it in that spot. Kind of put a little twist in it and then put it over that post and soldered it in place. So it's 1 wire twisted around that post and then goes on to wherever it connects. Either way, they could have came with 1 wire, cut it off, put another wire on, went on, but that's how they chose to do it here. And I've seen that before, but thought I'd show you that. Okay, so let's take our negative side, our negative lead here. It's going to go to our negative side over here. I'm going to just put it up through that little loop I just showed you. And we'll pull that loop then tight against that lead. If I can do that. And then we will wrap this other one around it. Like
that. And let's solder that. Let's clip this lead off here. So now what we need to do is connect the positive side of that electrolytic, which involves that resistor that we're replacing. So I think we're going to call it quits for this episode. And next time we'll come back, we'll hook up that positive side of the electrolytic and we'll start checking and replacing resistors. I hope you're enjoying this restoration and please subscribe to the channel. Thanks for watching and I'll see you in the next one.